Okay, so when we look at this, we now want to find the components of the force. And what we're going to do is we are going to find its line of action. Okay, we're going to take a vector. We're going to use a little what we call unit vector, or that lambda vector, and determine to help us describe how this is going. Okay, the direction it's going. So first we're going to figure out how far in the x direction we go, how far in the y direction we go, and how far in the z direction we go. And it's just going to be looking at the difference between these 2 points. Okay, so to go from point A to point B, okay, so I'm going to do d, oh my goodness, d sub x. And to do that, I'm going to take final minus initial. Okay, so I'm going to have 0 minus 40. Okay, so that means d sub x is going to equal a negative 40 meters. And that makes sense because from A, I'm going backwards in the x direction 40 meters to get to where B is at. Okay, so we're going to do the same thing for d sub y. Okay, so d sub y is going to equal where I end, 80 minus where I started, which is 0. Okay, so this is going to be 80 minus 0. So that means d sub y is equal to 80 meters. Okay, we're going to do the same thing for d sub x, or sorry, d sub z. Right, we're in space. Okay, so the distance in the z direction, I'm going to go from where I end, so that's going to be 0 minus a negative 30. So that means d sub z is going to equal 30 meters. Okay, so I still have to know the length, right, of this line from A to B. But now I can use these components to find that. Okay, so this is where then I use the Pythagorean theorem, but just apply it, right, to this situation. So we're going to have d is going to equal the square root of d sub x squared plus d sub y squared plus d sub z squared. Boy, that is not straight, but that's okay. Okay, so d is going to end up equaling the square root, so d sub x is a negative 40, so I'm going to do a negative 40 squared plus 80 squared plus 30 squared. Okay, so d ends up being 94.3 meters. Okay, so what I'm going to do now is I am going to define lambda, okay, or that unit vector. Okay, so to do that, all I'm going to do is I'm going to take d sub x over d, and that's going to be I hat, plus d sub y over d j hat, plus d sub z over d k hat. Okay, that's my formula to figure that out. Okay, so let's do that. We're going to take lambda equals d sub x, so that's going to be a negative 40 divided by 94.3 I hat plus d sub y is 80 meters. So we'll do 80 divided by 94.3 j hat plus 30 divided by 94.3 k hat. Okay, so to get our lambda vector, or our unit vector, okay, what I am going to end up with, oh, hold on, my calculator just went crazy. Hold on. Okay, so if we take this negative 40 divided by 94.3, we're going to get a negative 0.424 I hat plus 80 divided by 94.3 is a 0.848 j hat plus 30 divided by 94.3 is 0.318 k hat. Okay, so I can kind of read those. Okay, so if we look at the previous slides that we were talking about, we know that vector f is equal to f, the magnitude of f times the unit vector, okay, or lambda. So all that we have to do is we are going to take a scalar and multiply it by a vector. That's all that we're doing. Okay, so to find vector f, all I really have to do then is take the magnitude, which is 2,500 newtons, and I'm going to multiply that by a negative 0.424 to get my x component, and then I'm going to take the y component. Okay, so I'm going to take that 2,500 again, multiply it by the y part of lambda, that's 0.848 j hat, plus that 2,500 newtons again, and multiply that by the z part, okay, or the z component of my unit vector, 0.318 k hat. Okay, so that means when I do this multiplication, I'm going to end up with a negative 1,060 newtons I hat plus 2,500 newtons times 0.848, that's 2,120. 2,500 times 0.318 ends up being 795. Okay, so there is my vector. And you know what? That answer is completely appropriate. Now, if I want to know the direction of the force, okay, if I want to find the direction of the force, all I've got to do is take f of x and divide by f. So if I really wanted those direction angles, I could do the cosine of theta x is going to equal f sub x over f. Now I already know f. That's 2,500 pounds. We know that. Okay, so this is just going to equal this x component right here. So I'm going to have a negative 1,060 divided by 2,500. Okay, and my theta x is going to end up being 115. Oops, not 155. 115 degrees. Okay, so if I do that for the y component, I'm going to take 2120 and divide it by 2,500. And for theta sub y, then I'm going to get 32 degrees after I take the inverse cosine. Okay, same thing for theta z. This time it's just 795 divided by 2,500. So that means theta z is going to equal 71.5 degrees. Since that one's right in the middle, we'll put 0.5 on that one. Okay, so I'm just going to see, does this make sense? So if theta x is 115 degrees from the positive x-axis, so if this is my positive x-axis right here, let's change colors real quick. Okay, so let's just say this is my positive x, right? That's definitely over 90 degrees. So 115 degrees sounds right. Okay, so now we want it with the y-axis, okay? So from the positive y-axis. So if I go up like this, oh, yeah, I'd say that's about right. And the positive z-axis is right here, and that is this angle. That's that theta z. That's definitely less than 90. So I'd say that those make sense. Okay, we will do one other problem like this in the next video.